Welcome to table for 92, element number 91, Protactinium. It's number 91 because it has exactly 91 protons within its nucleus. For Protactinium, we're cooking up some pierogies to honor the Polish-American chemist Kazimierz Fajans, who led the team to the discovery of number 91. So first off, protactinium is like a lot of these extremely heavy radioactive elements. It's a silvery metal when in pure form, but that doesn't occur in nature. It has to be extracted, and it has no use outside of research. It's not found in foods unless something has gone really, really bad. And on the outside, it's not that interesting. Honestly, with a lot of these heavy radioactive elements on the bottom of the periodic table, the story behind how it was discovered, it's probably the most fascinating thing about protactinium. So, like so many elements, protactinium went through many iterations among scientists all over the world before someone could truly stand up and say conclusively they had proof of the existence of number 91 on the periodic table. And of course, there were instances before it was absolutely certain that other peoples had made about its discovery, but yeah, even giving it a name only to, be admonished later, and the research had to continue on. So yeah, like a lot of mistakes on the way to number 91. If you were to Google who discovered protactinium, the names that come up are Kazimierz Fajans and Oswald Helmut Göring. Sure, they usually get the credit, but this kind of goes back to the fundamental question: when does someone get credit for discovering an element? Like, is it when someone's able to prove its existence before they have tangible proof? Is it when someone studying a mineral realizes that there's an unknown element inside, but they can't extract it? Or is it when the element is predicted to exist, like when Mendeleev produced the first coherent periodic table? Well, all these questions and more will be answered in the next few minutes, so buckle in. Here's the insane history of protactinium, that element that confused scientists for generations and of today still has no real use for us outside of research. Pierogies, arguably the most famous Polish food in the world, and definitely the most common Polish food you can find in the US. Before the pierogies get started though, you need to make a sauce, right? I'm doing a cucumber yogurt sauce. It's very mild, it's very, very refreshing. So hollow out the seeds from the cucumber and peel off the skin. You need a fresh cucumber for this. The grating that you have to do of it, it's almost impossible if it's not fresh. Once grated, you put that in a strainer, add some salt to bring out the water, and same thing with the yogurt. 2 cups non-fat plain yogurt, set in cheesecloth, put some salt in there, and you let the moisture get out. You can do this the night before you're making the pierogies. You'll be surprised how much water comes out of the cucumber and yogurt, seriously. So 500 grams all-purpose flour, 2 eggs, 2 tablespoons room temperature butter. Using a pastry knife, you just chop up all the ingredients together, slowly adding 200 milliliters hot water until you get a nice dough, and you're gonna knead that for like 10 minutes. Filling, delicious, simple pierogies. I'm sure Kazimierz Fajans ate a bunch of these growing up in occupied Poland. Yeah, Fajans was born into an occupied country since the Polish-Lithuanian Commonwealth had been broken up, dissolved by their neighbors, and swallowed up in 1795 before gaining independence after World War I in 1918. So yeah, when Fajans was born, he was in an occupied country, basically. He went to study in Germany in 1904, got his PhD in 1909, and before he found number 91, he did really important work. He was the first to determine the half-lives of a bunch of isotopes in the uranium-actinium series. He also figured out half-lives of thorium isotopes. Yeah, it's been 10 minutes. We pretend it's been 10 minutes. Set this dough aside and cover it up for another 10 minutes. It'll be nice and firm then, and then we can fill it with beautiful mashed potatoes. So the true beginning of this story is with the immortal Dmitry Mendeleev, that Russian chemist who first put together the elements, or the known elements at the time, into a chart that everyone could understand. While he wasn't the first to put a chart together, his table definitely made the most sense and gave us insight into the elements yet to be discovered. The first table Mendeleev put together doesn't look anything like, this one over here. But what it did do was to gather the known elements into groups based on their similarities and based on the lightest to heaviest, which would help to predict the new generations of elements that could be discovered. It was an incomplete puzzle, but at least you know where the missing pieces are, and by the transitive property, what the missing pieces should weigh. Mendeleev himself said about number 91, quote, "Between thorium and uranium, we can further expect an element with an atomic weight of about 235. This should form a highest oxide, X2O5, like niobium and tantalum, to to which it should be analogous, end quote. But yeah, Mendeleev was never going to find number 91 himself. A lot that had to happen before that could be unearthed. But man, he was good. The atomic weight of number 91 is 235. You have to mention that while radioactive elements like uranium and thorium had already been discovered by the time the periodic table was published, people didn't know about radioactivity yet. So that had to happen. I've covered this before, but it goes something like this. This guy, Roentgen, was basically playing with uranium salts and accidentally discovered X-rays, and he hilariously experimented on his wife where he showed her an X-ray of her hand, and she freaked out and thought he had like created a machine that shows you your death. Great prank, just wonderful. They stayed married though. But yeah, then Becquerel and the Curies came in. They're able to actually describe and define radioactivity. And the Curies, they go on to discover radium and polonium and pitchblende, which is a uranium ore. And that number 91 would also be eventually discovered in pitchblende. But radium and polonium both were discovered in 1898. And the search was on to fill in the rest of the table. And that happened really quick. In 1900, Sir William Crookes of Great Britain seemed to figure out that while studying uranium ore, there was some other radioactive stuff going on in there. He named it uranium X for, unknown uranium. Same reason X-rays were named, so X-Files, right, unknown. So uranium X turned out to be two other different substances that Crookes would call UX1 and UX2. It would turn out that UX2 would be the one Kazimierz Fajans would study in 1913 a little later on. So there was a pretty good gap, like 13 years in between. Okay, before we get into Fajans and Göring figuring out number 91, let's finish off the pierogies. Separate this into like 4 equal-sized pieces. What you're not using, put back in the glass bowl and cover up because this dough dries out really, really fast. You don't really need to flour the surface, but you can if you want to. You basically want this to be as thin as possible, like ravioli. I mean, pierogies, it's essentially ravioli or like dumplings. Cultures all over the world have something along this line, or calzones, right? It's nice dough filled with something sweet or savory, wrapped, boiled, fried, whatever. It's the best, right? You basically want the pierogies to be like 4 inches wide when you cut them out. That's going to be enough to, really get enough filling in there to make sense. Yeah, I haven't had an opportunity to knead this rolling pin for a while, but this is like 150 years old. My great-great-grandmother brought this over from Sweden when they immigrated to the United States. But yeah, it always gets me how much smaller their hands were back then. So I'm just filling this with mashed potatoes. I'm sure you guys at home know how to make mashed potatoes. For me, the secret really, it's a ridiculous amount of butter, heavy cream, and salt. That's the secret to any good restaurant, like anything. You put an ungodly amount of salt and butter and the heavy cream in there. That's the restaurant secret, basically. It's horrifying, like how much you actually do when you work in a restaurant, how much butter and salt goes into everything. So that's why, it never tastes good at home. Okay, so you get like a spoonful of mashed potatoes into your dough, sprinkle in some paprika, and close up your dough, trying to get as much air out of it as possible. The air will cause it to explode when you boil it if you don't get it all out. Of course, there are tons of fillings that you can put in, but the most basic recipes are the most difficult. These are the classic recipes going back hundreds of years where people didn't have access to the kind of ingredients that we do now. So they had to figure out how to make these simple dishes taste really good. All right, so this amount of dough total makes like 15 pierogies. I'm just gonna make these 4 real quick. While making it, you gotta work fast because this dough dries out. You can kind of see the first pierogi I made looks great. The last one, not so much because the dough is drying out like that quick. So number 91 was isolated by Fajans. Well, really an isotope of 91. Today we call it Protactinium 234, but it had a half-life of just over a minute. So, that led Fajans to name it brevium, Latin for brief, as, it barely existed. 3 years later, during World War I, there's a German physicist, Lisa Meitner, discovers a much more stable isotope of brevium 231. But there's like this weird tradition at the time that you name an element after its longest lasting isotope. So the name brevium was abandoned and replaced with protoactinium, which was confusing for people, so they shortened it to Protactinium, which kind of sucks because I think brevium is a way better name and way less confusing than naming it after the first proto of another element, actinium, number 89, because now we have actinium and protactinium. Anyway, actinium is produced through the radioactive decay of protactinium, but it's just a silly name, and they should have stuck with brevium. If protactinium actually had any real uses today, maybe we would change the name, but since no one seems to care, here we are with another silly name. Who gets the credit? Obviously Fion's, but you can see the progression of the evidence that led to the discovery of protactinium, but then, he doesn't even get to name it because of this weird tradition about the longest lasting isotope. We like to make things easy by just saying oh yeah, this guy found it. But the story's always more complicated than that. It's a group effort over generations. Add the strained yogurt and the cucumber together, half a cup of sour cream, a little lemon juice, and finish it off with a handful of finely chopped dill. Add salt, coarse black pepper. So today, there are no large-scale uses for protactinium. The British Atomic Authority was actually able to produce 125 grams of protactinium, which comes out as a soft silvery metal in pure form, and they had to get that out of 60 tons of radioactive waste. So 125 grams out of 60 tons. That apparently has been really the only attempt ever to make large amounts of protactinium, large, 125 grams, and they sent it all over the world to different laboratories for research purposes, so that's all we really have of it. All right, so going back to the beginning, you remember me saying that Fion's was Polish-American? After having worked in Germany for over 20 years, making really important discoveries in chemistry and physics, these important laws and methods that are still used today, Fion's suddenly found himself unwelcome in his adopted country. He was Jewish. It's 1930s Nazi Germany. He was one of the lucky ones in Europe. He was able to emigrate. A lot of Jewish people living in Nazi Germany were not approved to move to other countries to emigrate in the years leading up to the Holocaust, and a lot of people were trying to get out. They saw what was coming, but Fion's was approved probably because of his expertise in chemistry and physics. He got out, moved to the United States. Yeah, if you've watched Oppenheimer, look through the people that worked on the Manhattan Project. A huge part of that was made by European Jewish refugees. So yeah, Fion's got out in 1935. He worked at the University of Michigan, where he would stay for the rest of his life. I think, honestly, this is the 5th Jewish scientist that fled the Nazis and moved to the US that was involved in the discovery of an element we've covered in the show so far. A lot of you went on to work on the Manhattan Project. But yeah, Fion's definitely didn't shed his Polish roots, though. When he was living in the US, especially Midwest, United States has huge Polish population, and he joined the Polish Institute of Arts and Sciences and was a member of the Polish Chemical Society while living in the United States, and he discovered number 91, an isotope, but not the longest living isotope, so that we get the silly name protactinium instead of brevium. Well, that was protactinium, and this is a delicious pierogi. One of them did explode though, but I think I could have impressed Fion's with this. I don't know. That's fantastic. Thank you. See you next time.